right now I want to look at the elevational view of surfaces and understand how they work. Previously we were talking about this rammed earth one, and of course I'm using this rammed earth because it's interesting, but also because it's a surface that I've created. Because we can create surfaces, we can also create the way that they look in elevation. In this case, that's been defined by a fill. So when we look at this in elevation, we see that this wall, we selected this wall before. Let's see if it's the same one. Yep. So we see that we overrode those surfaces. And like I said before, we don't need to override those surfaces to say rammed earth, rammed earth, rammed earth, because we already see that the building material is called rammed earth, and the building material uses the surface already that's called rammed earth. So we can unclick those, unclick the override, and that'll mean that it's still representing properly. Now, when we go back into that setting, apart from the override surface, what are we looking at? There's no other real setting that's defining what we're seeing here except for the fact that this is now the building material. So let's go to the building material and understand how that works. So we can do this again, similarly as before. Alt, pick up settings, click, options, element attributes, building materials. Once we're in our building materials, we need to find the rammed earth, AED rammed earth. Now, we need to look very carefully at all these different settings because this is going to help us understand how it works. When we're talking about a building material, we have a structure and appearance. So we see that if I'm cutting through the rammed earth in plan or in section, I'm using a fill called AED render to represent what we see. If we're seeing the rammed earth in elevation, then we're using the surface called AED rammed earth, and we can see here that this surface has both a vectorial hatch and a texture applied, and we'll go into that in a minute and make more sense of that. What's else important here? We have a pen weight for how it looks in plan, and we have a intersection priority for how it intersects with other building materials. Now this is set very, very high. It's unlikely that it would be this high. We'd probably want something like concrete to be slightly higher than the rammed earth. But for now, we'll just leave that as it is. Let's go into the surface again. Options, element attributes, surface. Rammed earth. We were in here before, but just to clarify, we were looking at the texture. So the texture is the picture that we see there in terms of its symbol, but we also see it has a vectorial hatch, and that's a fill. So if I click here, we're looking at the range of fills. This one's called rammed earth. And we see that we have a different pen assigned to that one. That's pen 1 because we don't want the pen to look very thick on elevation because that wouldn't look appropriate. Let's go into that one now. It's slightly confusing maybe because they've all got the name called rammed earth, but when we go into our fills, we can then find it by scrolling down. This one wasn't prefixed from memory. When we're talking about fills, we have solid fills, vectorial fills, and then symbol fills. And these all work in different ways. And so we see that they're all in alphabetical order, but they're in different categories of alphabetical order, which makes it sometimes hard to find what we're talking about. Here we have AED rammed earth. We have another one down here called rammed earth. In this case, this is the one that we're using, but both of them could potentially be used. We just see it's a slightly different way that it's described. Now what we're looking at is a set of lines which is being repeated over and over again, which is creating this pattern of the striation of the rammed earth that we see. And we can see that these are being used, or we're able to use the fill in multiple different fashions or ways. These are all the aspects that go into creating this building material, go in creating this surface, and what we see in elevation. Now I could change the representation, as I talked before, of the color. So if we go to rammed earth, and change the surface color, let's say we make this a darker yellow, we see that changes the elevational representation of it. So when I'm trying to create an elevation, I don't necessarily want this color to be realistic of the material, because in a lot of situations I'll have black materials or very, very dark materials, and my elevations will look hard to read, look too dark if I use very dark or in this case true realistic interpretations of the colors that I'm trying to represent. So instead I want to create more muted colors or more pastel versions of the colors that I'm trying to represent. So for instance, this one here, this cladding is supposed to be a charcoal cladding. We see that's called AD Fire Crunch Charcoal, but when we view this in elevation, of course, that's nowhere near charcoal, because if I made it charcoal, it would be too hard to distinguish the lines and then wouldn't tell a very good story in elevation. So we have to remember that when we're doing architectural drafting, the elevations are telling a story. It's not about necessarily representing reality, it's symbolic. That's different when we're creating a photo render. Generally speaking, in a photo render, we're trying to mimic reality as much as possible. And that's why we'll use a real surface, a real texture to represent that, rather than using a two-dimensional representation of it that we get from a fill.